Alright, welcome to the last page of the notes, and we're just going to find volume now. So if you recall, if we just want to find volume of a solid, it's just going to be the triple integral, alright, dv, and everything's going to be defined by our integrals. And so this is how we can find volume. So we're going to go ahead and find volume, but we need to kind of know what the shape looks like. It says that we have a sphere. And so the sphere has a radius 4, but it also has a cylinder that lies inside of it that's defined by x squared plus y squared equals 1. So this is kind of the shape that we're dealing with. I'll go ahead and just draw it. So here's our sphere. All right, and inside this sphere, and I'll go ahead and color it in. So inside this sphere we have right here, with the radius of 4, inside that we have a cylinder of radius 1, that is cutting through that circle. And so we have, another circle that matches that. It's coming out of it. Another one as well. And so what we want to do, we want to find the volume that's in red, because that lies within both the cylinder x squared plus y squared equals 1 and the sphere x squared plus y squared plus c squared equals 4. So what we need to do is we need to define this top region and this bottom region for z. So we need to define, okay, what's the top region, what's the bottom region, all right? And we already have, what we can do for polar. That's just going to be the circle x squared plus y squared equals 1. So I'm going to go ahead and set up my polar part. My polar part is going to be from 0 to 2 pi. And my radius is 0 to 1. Right? Because, again, we're just focusing on what's in red. And now, the lower half of my circle is defined by, and I'm going to define that up here using my equation. So I'm going to go ahead and solve for z. So z squared is equal to 4 minus x squared plus y squared. I'm just going to have those both together. Square root that, z is equal to the square root of 4 minus, and I'm going to go ahead and change x squared and y plus y squared to be r squared. All right, so now that I have that in cylindrical coordinates. Oh, sorry, plus or minus. So that gives me top and bottom. The top would be positive 4 minus r squared. And the bottom would be negative square root of 4 minus r squared. And so that takes care of the top and the bottom. Takes care of that part and that part. And now I need my volume, so r dz dr d theta. All right. And now I'll just go ahead and evaluate, which is the easy part. This whole thing, you might think, oh, this whole thing is the easy part. All right, so let's go ahead and evaluate. We have no z's, so we go from 0 to 2 pi, 0 to 1, and we just are left with zr from negative radical 4 minus r squared to positive radical 4 minus r squared. Dr d theta. Go ahead and substitute in. And we're going to get the integral from 0 to 2 pi, 0 to 1. I'm going to get, I'll just write it out, r squared of 4 minus r squared minus r times a negative square root of 4 minus r squared. So really there's just two of those. Dr d theta. So this is going to be a positive 2r square root of 4 minus r squared. So we're left with 0 to 2 pi, get that 0 to 1, and 2r square root of 4 minus r squared dr d theta. And again, notice, hey, I have radians and thetas. I don't have nothing but radians in the integral, so let's go ahead and break that up. 0 to 2 pi d theta, and the integral from 0 to 1 to r radical 4 minus r squared dr. Now, again, the outside integral, 0 to 2 pi d theta, is just going to be 2 pi. Integrate this, hopefully, this is going to be u substitution. And u would be 4 minus r squared, so du would be negative 2r. So I'm going to need a negative when I integrate. And then it was to the 1/2 power. I mean, it's right now to the 1/2 power, so it means it was to the 3/2 power. So I need to multiply by a 2/3. So it's going to be negative 2/3 4 minus r squared 3/2, going from 0 to 1. All right. Now we just go ahead and plug in. And the first part, I get 2 pi. When I plug in 1, I get 1 squared is 1. 4 minus 1 is 3. 9 2/3. We'll just go ahead and say that's going to be 3 to the 3/2. When I plug in 0, I'm going to get 4 to the 3/2 times negative 2/3. So 4 pi over 3. Make sure all the math is correct in my head. Alright, yeah. Alright, so negative 2/3 times, when we plug in 1, that's going to be this is going to be 3 to the 3/2 power. And then minus, plug in the next one, we're going to plug in 0, that's going to be 4 squared 16, and no, just take the square root of 4, which is 2. 2 cubed is 8. I don't know why that was difficult to do in my head. And so I'm going to pull out the negative 2/3. Actually, I'm just going to rearrange what's on the inside. So I'm going to say 8 minus 3 to the 3/2 power. So I just changed that negative to get rid of the negative 2/3. And so then it's just going to be 4 pi over 3. All I did was distribute that negative of the 2/3 into there, just to rewrite it so I could have that 8 in front and have that nasty 3 to the 3/2 power in the back. All right, the last one is set up but do not evaluate, which is nice because it takes care of a lot of work. Find the volume of the solid that is enclosed by the cone z equals square root of x squared plus y squared, and the sphere x squared plus y squared plus z squared equals 2. All right, so let's just go ahead and set up the situation. So we got a cone, and so this is the square root of x squared plus y squared. So real quick, this is going to be z equals the square root of r squared, which is just r. All right, this cone is going to be facing upwards because z is positive. And the sphere x squared plus y squared plus z squared equals 2. And so let me just draw the sphere real quick. And so we're looking for this area right there. All right, let's solve this equation for z. So z squared is equal to 2 minus x squared plus y squared. Square root that. Z is equal to the square root of 2 minus r squared, plus or minus. But notice if that's going to be, the xy plane, this is going to be where z is positive. So therefore, we only need the z, because we only care about this portion of our circle right there. No, you can't really see that color. Let's do blue. We only care about this portion right there, and that portion is going to be taken up by the positive z, so it's z square root of 2 minus r squared, and so that's going to be on top. All right, now we want the point of where they intersect. So what we can do is we can set these two equal to each other. Because we want to find, okay, it's where they intersect, it's actually going to intersect, a circle right up here. All right. So if z is equal to the square root of 2 minus r squared, and that's equal to, and z is equal to the square root of r squared, square both sides, get rid of the r squared, so we get 2 minus r squared equals r squared. Bring the r squared over, so we get 2 is equal to 2r squared. Divide both sides by 2, we get 1 equals r squared, so r equals plus or minus 1. Radius is always positive, so r equals 1. So that gives us the radius of where they intersect. So therefore, I can go ahead and set up, it's going to be a circle, so 0 to 2 pi. The radius is going to go from 0 to 1. And then we have an integral from the lower half, and our lower half is defined by r. All right, that's that lower half that we have on the bottom, so r. The top half is going to be defined by z equals the square root of 2 minus r squared, so the square root of 2 minus r squared. And then all we need to do now is just write in the integral, because again, we're looking for volume, so it's the triple integral. And so our dv is going to be r dr d theta with dz, so dz dr d theta. And again, we don't